Dear student, today is the second part of chapter number 1, that is the rational numbers. In the first part, we have completed up to the existence of additive identity. We have completed up to the existence of additive identity, that is a roll of 0. So today we have, in the second part, we have to continue about the fuse fuse properties again. So this is the second part. So here is existence of additive inverse. What is the additive inverse? Let's see here. If P by Q is any resonant numbers, then there exists a resonant numbers of minus P by Q such that P by Q plus minus bracket minus P by Q, P by Q plus bracket minus P by Q bracket close is equal to 0. So minus P by Q bracket plus P by Q, where minus P by Q is called the additive inverse of P by Q. It means that additive inverse means to find the additive inverse of any rational number, what we need is we need to change its sign. If P by Q is in form of positive, then in case of additive inverse, the sign will become minus P by Q. In this way, we can say that existence of additive inverse of any rational numbers is a changes of its sign. It means that if it is P by Q is a positive, then you have to change the sign, that is minus P by Q. It should be in the positive. If it is in the negative, then it should be in the positive, and if it is in form of positive, then it should be in the form of negative. So that is the additive inverse of any rational numbers. Next we have the existence of multiplicative inverse, that is reciprocal. To find the additive inverse of non-zero rational numbers, interchange the position of numerator and the denominator. In case of multiplicative inverse, that means reciprocal. To find the multiplicative inverse of non-zero rational number, then what we have to do is that we should interchange the position of numerator and the denominator. If PQ by P is the additive inverse of P by Q, it means that the additive inverse of P by Q is Q by P, because it says that numerator and denominator position of numerator and denominator should be interchanged. Then P by Q is also the additive inverse of Q by P. So whenever a number is given like 1 by 2, 3 by 5, then what is the additive inverse of 3 by 5? Additive inverse of 3 by 5 is 4 by 5. 3 by 5 is 4 by 3. 3 by additive inverse of 3 by 5, it means that 5 by 3. Likewise, we have to change the numerator position of numerator and denominator. Or else we can say that the multiplicative inverse is that when the product of two number is 1, when the product of two number is 1, they are said to be reciprocal of each other. Okay, if the product of two number is 1, then the we can say that they are said to be the reciprocal of each other. It means that 7 by 2 into 7 by 2 by 7 into 7 by 2, the answer will become 1. So it means that 2 by 7 is a reciprocal of 7 by 2. Understand? In this way also we can say that. Or we get the reciprocal of the fraction by interchanging the denominator and numerator. This is also another example. There are a few definitions that we can understand about the multiplicative identities. Multiplicative inverse. That it means only the things you have to know is the reciprocal. In case of reciprocal, what we have learned in earlier, reciprocal means interchanging the numerator position of numerator and denominator. That much. Okay. The next one is existence of multiplicative identity. Multiplicative identity. that is a roll of 1. The rational number of multiplied by 1 is the rational number itself. If the rational number p by q is multiplied by 1, then the resultants of the answer will be always p by q. Understand? If any number multiplied by 1, then the answer will be number itself. So if p by q is any rational number, then p by q into 1 is answer will be always the number itself. So we say that 1 is the multiplicative identity of rational numbers. Understand? We call it 1 as a multiplicative identity of a rational numbers. These are the 1, 2, 3 parts. That the first one is the additive identity. In case of additive identity, what we have to do, any rational number, then we need to change the sign. If the rational number is in form of positive, then in the another side it should be in a negative. Multiplicative inverse, that is a reciprocal. Reciprocal means what? Interchanging the numerator and the denominator, position of numerator and denominator. And the second one, the third one is multiplicative identity, that is a roll of 1. When you multiply by 1 with any other numbers, then the number itself will be the answer. So we say that 1 is the multiplicative identity of the rational number. The last properties, it's very important property, that is distributive properties. This is the last property. See, multiplication of rational number is distribution over addition. Distributive property of the multiplication over addition. There are two types: distributive properties of multiplication over addition and over subtraction. The first one is for addition. The second one is for subtraction. See, let's see. In the distributive property of multiplication over addition, it is said to exist if there are three numbers, that is three rational numbers, that is p by q, r by s, and the u by b are three rational numbers. Then p by q into bracket r by s plus u by b bracket close is equal to p by q into r by s bracket plus p by q into u by b. It means that if p by q multiply here in the first numbers and multiply again in the second number, in the first number it should be multiply p by q into r by s, and again in the second number, and in the third number p by q by u by b. The answer should be both the left hand side and the right hand side answer will be always same. Understand that this is a properties of distributive property of multiplication over addition. And the second one is distributive over subtraction. Same thing, the sign will change here. Instead of plus, instead of addition, here the sign will be subtraction. So in this also, first number, second number, third number. If you multiply first number, second number minus first numbers and the third number, the answer of the left hand side and right hand side will be always same. Understand? The answer of the left hand side and the right hand side will be always same. So we can prove this is the last properties of this lesson. We have discussed all the properties like closure property, commutative property, associative properties, and this one is the last property, that is distributive properties of multiplication over addition and the subtraction. We can have addition and the subtraction. So we can verify these two properties by giving the examples. Okay, let's see with two examples of addition and multiplication over additions and multiplication over subtraction. Let's see the examples. Let's calculate the example and let's verify these two properties. The first one is the distributive property over addition. Let's see the examples. Here, this is the distributive properties of multiplication over addition. These are the, we need to verify these two numbers. One is left hand side and one is the right hand side. Here this is, you can say that this one is P by Q and this one is R by S plus U by V, we can say. So first we need to find out, this one is the left hand side and this one is the right hand side. We need to prove that left hand side is equal to right hand side according to the distributive properties of multiplication over addition. So this one is the left hand side. So first we will find about the left hand side. 3 by 4 into minus 1 by 3 plus 5 by 6 is equal to, if you multiply this 3 by 4 into, if you take the LCM of 3 and 6, the answer will be always 6. So if you divide these two, the answer will be 2. 2 into minus 1 plus this one divided by 6 by 6. 1 into 5 is 5. So here answer here comes 3 by 4 into, the answer will come here 3 by 4. Here comes minus 2 plus 5 by 6. Right. So 3 by 4 is equal to into minus 3, minus plus 3, 3 by 6. Then the answer will become 9 by 24. We can put in the lowest term, that is 3 by 8. The left hand side is, the answer of the left hand side is 3 by 8. And here again in the right hand side, let's see the right hand side. In the right hand side again, this also P by Q by R by S, and this one is P by Q by into U by V. That formula that we have used in the distributive property. Here in this case also we have to take the LCM here. So here what we have to do first is that we have to take the this third bracket and this is the first bracket, so we have to multiply both. So first 3 by 4 into, this will come in both, into minus 1 into 3. Understand? Here in that side, that will come 3 into 5 by 4 into 6. Right. Here comes, the answer will be, here in this side, minus 3 by 12 plus here comes 15 by 24. So what we have to do is that we can put this all, take the LCM of minus 3 by 12 plus LCM of 12 and 24 is 24. So if you divide 12, 24 is 2 into minus 3 plus, if 24 is 15. So the answer is minus 6 plus 15 by 24. The answer will be minus, this will take minus, that's 9 by 24. If you took the lowest term, then answer will be 8 by 3. So here we can verify 3 by 4 into minus 1 by 3 plus 5 by 6 is equal to 3 by 4 into minus 1 by 3 in plus 3 by 4 into 5 by 6. This means that this is a distributive property of multiplication over addition. This is the first part. That means P by Q into R by S plus U by V is equal to P into Q into R by S plus P by Q into U by V. Understand? This is the property first, distributive properties of multiplication over addition. And again, we need to verify the second part, that is the distributive properties of multiplication over this one is over subtraction. We need to verify this also. Here, this one is a left hand side, this one is a right hand side. So we need to verify first the right hand side, left hand side. In the left hand side, we know that 2 by 3 into here's come. If you take the LCM of these two, the answer will be 10 to 4 minus 7. 2 by 3 into minus 3 by 10. Then answer will be minus 6 by 30. So if you divide by 6, then answer will come 1 by 5. In the left hand side, we got the answer 1 by 5. So we need to find out in the left hand side also, right hand side also. This one is the left hand side and this one is the right hand side. We need to prove whether this properties of distributive properties multiplication over subtraction is true or not by using these examples. In the left hand side, we got minus 1 by 5. So let's see in the right hand side whether the answer is correct or not. See, in the left hand side, we got 2 into 2 by 3 into 5 minus 2 into 7 by 3 into 10. Then here comes 4 by 15 minus here comes 14 by 30. If you took the LCM of this 15 and the 30, you get LCM of 15 30 is 30. So if you divide 30, that is 2 into 4. If you divide 30 by 30, 30, then the answer is 14. So here comes 8 minus 14 by 30. The answer will come minus 6 by 30. If you divide by 6, then answer will come 1 by 5. Here's again. Here it's come. This one is the right hand side. This one is left hand side is equal to right hand side. So that we can prove that. So 2 by 3 into 2 by 5 minus 7 by 10 is equal to 2 by 3 into 2 by 5 minus 2 by 3 into 7 by 10. So the distributive property of multiplication over subtraction. This is another property. So we can prove it. We prove it. P by Q. This one is in form of P by Q. So likewise, we have calculated two examples. For the first one is distributive properties of multiplication over addition. We have proved. The second one is distributive property of multiplication over subtraction. Also, we have proved. Understand? After verified the there we have calculated two examples of this distributive property of multiplication over addition and over subtraction. Now we have another examples to solve the distributive properties of multiplication. One is over addition and one is over subtraction. Let's see. two examples we have to discuss now about the distributive properties. This is an example we need to discuss. Solve using distributive properties of multiplication. We need to solve this problem by using the distributive properties. Question number 1. Let's see question number 1. Question number 1 solution. Yes. Here minus 2 by 3 into 5 by 6 plus minus 2 by 3 into 7 by 6. So we can take common 2 by 3 minus 2 by 3, 2 by 3 can be taken as a in form of p by q. So like this. And what will it this? This 2 will be r by s and u by b. This will be put under the bracket 7 by 6. Understand? Here come minus 2 by 3. Now what we have to do is we have to take the LCM of 6 by 6. LCM of 6 by 6 is 6. Now come 5 plus 7 minus 2 by 3 into 13 by 12 by 6. Then the answer will be we can cut this 3 and this one is 4. So minus 4 by 3. Answer is minus 4 by 3. The answer will become minus. The answer will be minus 4 by 3. So this is in form of this minus 2 by 3 minus 2 by 3 is p in form of p by q, p by q. 5 by 6 is r by s and 7 by 6 is u by v. Okay, we can find out by using the distributive property. The answer is minus 1 minus 4 by 3. Let's see the second question again. In second question also we can find there are two common rational number 11 minus 11 by 8 and minus 11 by 8 can be put in as a common divisors. So into here's come 14 by 5 minus 9 by 5. This is multiplication distributive properties of multiplication over subtraction. The first one is addition, the second one is subtraction. So 11 by 8. Now what we have to do is we have to take the LCM. LCM is 5. So 14 minus 9. 11 by 8. Here come my minus 14 by 9 is 5 by 5. Then the answer will come 1. 11 by 8 into 1 is equal to 11 by 8. The answer is 11 by 8. So in the likewise, in this way, we can solve the distributive properties of multiplication over addition and subtraction. And the first one is how verified, means checking the rules of the distributive properties of addition and subtraction. We are checking whether the formula is correct or not. But here in this case we are solving the problem by using distributive properties of multiplication. Here is another example for the multiplicative inverse. Is 0.7 the multiplicative inverse of 1 by 3? Let's solve this problem. In the solution we have 1 whole over 3 by 7 is equal to 10 by 7, right? And 0.7 is equal to 7 by 10. Let's see whether the 0.7 and the 1 whole over 3 by 7 is a multiplicative inverse of each other. Now let's see. Here in this case the reciprocal 1 whole number 3 by 7 is 10 by 7, and the 0.7 is 7 by 10. Here comes what the multiplicative inverse say. If the two numbers reciprocals, that is 10 by 7 and 7. If you say that reciprocal of 7 by 10 is 10 by 7 is 7 by 10. So let's see. You multiply both, the answer will become what? 1. If the answer comes 1, what it says, 0.7 is a reciprocal. If you say here multiplicative inverse means reciprocal. Whether 0.7 is a reciprocal of 1 whole number 3 by 7? Yes, because we get the answer 1. So, yes, 0.7 is the, we can say that multiplicative inverse of inverse or reciprocal of 1 whole number 3 by 7. Very easy. Next, we will see the next example again. This is a example. These are the few examples. Now we have to discuss again. Multiply 6 by 13 by the reciprocal of minus 7 by 16. Now the first one is, these are a few examples because we have already learned all the properties, so we need to discuss about few examples according to the given properties. Okay, the reciprocal. Now the reciprocal of minus 7 by 16 is what? 16 by minus 7, that means minus 16 by 7. So multiply the reciprocal means you have to multiply the minus 16 by 7 into 6 by 13. So 6 by 13 into minus 16 by 7. You have to multiply now. 6 into minus 16 by 13 into 7. Now comes minus 96 by minus 91. This is the answer. So first you have to take the reciprocal of minus 7 by 16, and then the reciprocal answer will be multiplied by the 6 by 13. Understand? And the second example. Find the multiplicative inverse of minus 8 by 5 into 3 by 7. Now let's see. In this solution we have, after multiplication of these two numbers, we have to take the reciprocal of the answers. 7 by 3 is equal to minus 8 into minus 7 by 5 into 3. That is, minus minus is plus, so answer will be 56 by 15. Then find the multiplicative inverse. What is the meaning of multiplicative inverse? It means reciprocal. So multiplicative inverse of 56 by 15 is what? That means the reciprocal. 15 by 56. This is the answer we have. These are the two things that we have to discuss. This one is a reciprocal and this one is about multiplicative. Multiplicative inverse and the reciprocal is same. The answers is the question are different, but the process are same. So the next question we have, this is about the properties of divisions. So before we start these properties, we need to understand a few things about the properties of divisions of rational numbers. So listen carefully. So in case of rational number, we have, in the rational number, in case of division, we have, the first one is a closure property. This one is a closure property. Properties of division. Closure property. A set of rational number. Closure property is not under the not under the division, because if you take p by q, if you divide by p by q by 0, then both rational numbers, both are rational numbers, but if you divide p by q by 0, then the answer is not defined. So we can say that closure property is not under division. The second one is about the commutative properties. In the commutative properties, division of rational number is not commutative. In the commutative properties also, we can say that rational number commutative properties, division of rational number is not commutative because it doesn't work. It means that p by q, if you divide p by q by r by s, is not equal to r by s by p by q. Understand? The third one is associative property. In the associative properties also, division is not of rational number is not associative. Division of rational number is not associative. See, p by q, r by s, u by b divided by u by b is not equal to p by q divided r bracket r by s divided u by b. It is not under associative properties. So likewise, if you multiply, if the role of 1 in the division, if you divide any number by 1, the answer will be the number itself. If you divide in the rational number also, if you divide by number itself, then the answer will become 1. Means rational number divided by itself means the answer will become 1. There are two things you have to understand. Role of ones in rational numbers. Rational number divided by 1, it gives the rational number itself. And another next is a rational number divided by itself, means rational number p by q divided by p by q. The answer will be always 1. You have to remember. So here in the properties of division, closure properties, commutative property, associative properties, 1, 2, 3, these all properties cannot work under division. Years come, it is not defined. Commutative property also not defined, and associative property also not defined. So we can say that in the division, closure properties, associative properties, and the commutative properties are not under division. So next, according to that, we can say that these are the shortcut of the properties of division of rational numbers. So let's work out one examples according to the division, properties of divisions. Okay, let's see. Here comes the product of two rational number is minus 8 by 9. If one of the number is minus 4 by 15, find the others. We have to calculate this. So the first one is solution. One of the number is minus 4 by 15. The product is minus 8 by 9. So let the other rational number is x. So minus 4 by 15, if you multiply into x, it give minus 8 by 9, right? So if you want to put x, to find x, minus 8 by 9 divided by minus 4 by 15, x equal to minus 8 by 9. You have to change the reciprocal. Minus divide sign will change into multiply, and this minus 4 by 15 will be as a reciprocal. 5 15 minus 4. Understand? Now here comes x equal to minus 8 into minus 15, 9 into 4. Now we have to see the value of x. So you can divide these two. This one will be 5, this one will be 3, and this one also we can divide by 4, 2. Then come minus 2 into minus 5 by 3. Answer will be 10 by 3. The other number, therefore the other number will be the other number that is x will be 10 by 3, or 3 whole number 1 by 3. This is the answer. This answer for this question. Okay, so the student, we have concluded all the properties of the rational numbers. So today also we have discussed about the few properties of rational numbers. The last property, that is distributive properties. Here in this case, distributive properties can be worked under two things. So the first one is the distributive properties of multiplication over addition and subtraction exists for rational number, because both of them we can work, we can calculate, or we can solve the problems, we can verify. So it says that the distributive properties of multiplication over addition and subtraction exist for the rational numbers. Okay, and this additive inverse and the multiplicative inverse. Additive inverse, in case of additive inverse, has the same numerator and denominator. The numerator and denominator will be same as the number, but has the opposite sign. The numerators and denominators will be same. It will be not interchange. The only the thing is that we have to put the opposite sign. In the left hand side is positive, then in the right hand side, additive inverse will become negative sign. Whereas in case of existence of multiplicative inverse, that is reciprocal. In case of reciprocal, we have the same sign as numbers. The sign will be same, but numerator and denominator are interchanged. In the case of reciprocal, the sign will be there. If it is positive, positive will be there. But only things we need to change is the numerator and the denominator. Interchange of numerators and the denominators. These are the two things that we have to be understand. So dear student, here we will conclude the second part of chapter number 1. So we have discussed few examples of the distributive properties over multiplication over addition and subtractions, and a few examples and the properties of the divisions also. So today this is the second part of the chapter number 1, that is rational numbers. We will conclude part 2 here. Thank you.